Okay, appreciate y'all coming out for Math 1111 Zoom meeting tonight. Were the assignments clear this week? Y'all can go ahead.
Of questions like number 19 on 153 and number 11 on page 153.
Okay, those are the problems you want to see?
If you can, please.
Okay, sure thing. Let me start up the camera. We got Mr. Arnold joining us tonight. Let me start up the camera. I don't know why or how it's changed back to the vertical. Doggone. I don't know how that happens. Okay. All right, here we are. Let me see. Okay. All right. It's a bigger screen. Crap. My fault. I don't know what I'm doing wrong. Let me try again. Oh, come on. I can't get the widescreen to stay. What am I doing wrong?
Is your lock rotation on?
I don't even know what the heck that is. Remember, I'm a boomer.
Pull down your top settings on the top, and it should be like a little lock rotation thing.
Okay, so go to settings. You're saying go to settings?
Try to pull it from the top of your phone.
Okay, I'm back to...
Like the notification bar up top.
All right, okay. All right, here's my settings. You saying go to settings?
Well, not exactly. There's when you're holding your phone, if you pull it from the top, it should show like a couple of different settings. Okay, try the bottom one then. You probably
Right from the bottom?
Yeah, you probably have a different phone.
I got an iPhone 6.
Okay, and then do you see that little lock rotation thing? Try that. Maybe that'll help.
Well, that's probably going to lock it on vertical, isn't it? I want it locked horizontal. How do I get it? Oh, switch horizontal. Doggone. If I switch horizontal, then I can try to lock
maybe
it.
Just try leaving your phone in one position.
Yeah, I was. And then I'm hanging it up and it's switching back on me. Doggone. Okay. Well, I'm horizontal on the phone like I want to be. There's the screen lock. Oh, I see what you're saying. Yeah. But it's not showing that on the screen. I've got what I want on the... Let me stop the share and start from scratch. I apologize, we're wasting time. All right, let me share again. Okay, I'm trying to get it to go horizontal. And I'm holding the form horizontal and it won't go. I may have to call my technical assistant. He's downstairs watching watching TV. Yeah, gum, it won't go horizontal. Always got it to work before. Oh, I'm wasting y'all's time. Dad, gum. Maybe I've got the lock on. Okay. Okay. I don't know. I apologize. I'm looking like a doofus. Let me stop the share and try from scratch again. I can't get it to stop. Oh, my internet's. I'll try one more time. And switch back. I may just have to go with it. Okay. I may have to go with a narrow screen. I don't know why I can't get it to work on the other one. I'll try to write smaller. All right, let's see. Okay. Okay, can everybody see the pad?
Yes, sir.
Okay, I apologize for that. We'll just go with this then. I'll try to write a little bigger because it does look a little smaller on the screen. Can you repeat those pages and problem numbers? You called out some pages and problem numbers.
Oh, sorry. I didn't know I was on mute.
Oh,
It was
okay.
page 11 on one, or page 153 number 11, and then same page number 19.
And page 153, 19. Okay, these are from 1.8. 153, 11. Solve absolute value of x plus 4 equals 0.5. Okay, with an absolute value equation, then you're going to set up two situations. First one is pretty obvious. You're just going to set the x plus 4 equal to the 0.5. But you see, when this stuff is also equal to negative 0.5, you'll get a working equation. So the second one is x plus 4 to negative 0.5. Both cases, you're going to subtract 4 on both sides. I think you're going to find that that's negative 3.5. And when you do minus 4 and minus 4, I think you're going to find that's negative 4.5. Can you see the check? If I have absolute value negative 3.5 and add 4, I'll get a positive 0.5 equals 0.5. And over here, if I get an absolute value of negative 4.5, add 4, 0.5. Screen's freezing. Okay, barely read that. I try to write bigger. Then I get a negative 0.5 in between the bars. And you can see 0.5 equals 0.5 because the bars turn that negative to positive, and both of these check. Does that help?
Yes, I wasn't sure about the point wise and the negative part, if that makes sense.
Now, when you're saying the point, but you're talking about this point?
Yes, and then I had totally forgot I had to do it negative wise, so I was confused right there.
Yeah, see, you got both cases. See, if it's a straight x, absolute value of x equals 0.5, don't get thrown off by the 0.5. It's just another number. See, this is going to work if this is 0.5, and it's going to work also if it's negative 0.5. So with a straight x, you get x is 0.5 and x equals negative 0.5. It'll catch up with me. Well, when you've got other stuff inside or in between the bars, you wind up doing the same thing, except it's what's between the bars equal to 0.5 and what's between the bars equal to negative 0.5. In this case, your negative 3.5 keeps the bar positive, and that still makes 0.5. This case, this number turns the between the bars negative 0.5, but the bars turn it positive, making it still legal. Does that help?
Yes, sir. Thank you.
Okay. Yeah, you got to account for both cases. And you got to remember to do that. The first case hopefully is obvious. Just take what's here, set it equal to that. But then you got to remember to set it equal to the negative of that. You got both cases. If you want to try 19, yeah, that's going to have a little more algebra in it. We're on page 153. 8 plus 5, an absolute value of 1/3 x minus 5/6 equals 33. Okay, this one's kind of longer and everything, hard to fit on one page. Let's see if I can, there we are. Does this make you go, why did I sign up for this class? Occasionally I teach, we call it learning support now and remedial. I'm not doing it this semester. You guys aren't remedial, but I hope you're far enough along to resist, because this is what the remedial people want to do. See that 8 plus 5? They instantly want to go 13. Are y'all advanced enough to know not to do that?
Yes.
Okay, because you're violating your order of operations. You've added here before doing this multiply. But Guy, I just cannot break those remedial people of that. It's just so tempting to them. Okay, so what you want to do is basically you want to get this, the strategy here is to get this by itself. So there's going to be 2 steps to that. We're going to wind up subtract 8, and then we're going to divide by 5. So -8, -8, 5, absolute value of 1/3 x minus 5, 6. It's going to come up 25. Divide by 5. An absolute value of 1/3 x minus 5, 6 is going to come up equal to 5. Did we lose anybody doing that? Can everybody see this? Because it's a smaller screen, I'm trying to write bigger.
Yes, I can see it.
Okay, so you got the same strategy as the last problem. Whatever this is equals 5, and whatever this is equals -5, because both of these numbers, if I come up with absolute value of 5, it gets 5, and absolute value -5, it gets 5. So you've got a number 1 set. Your 1/3 x minus 5 over 6 equal to 5. And number 2, your 1/3 x minus 5 over 6 equal to -5.
I have a question.
Okay.
On the 1/3 x minus 5 or 5 over 6,
Right.
why did you subtract 5?
Okay, it's not that I'm subtracting. Oh, up here. Are you talking about this step?
No, I understand where you divided right there, but
Okay.
under it, right there. Where did, one more. Yeah, right there. Where did those 5s?
Well, that 5 came from dividing this.
Okay, I see that, but the arrow's pointing down. What does that mean? Is that
Okay,
subtracting
I'm just
5? Or
trying to, yeah, I'm trying to justify, or what you have to remember to go further is you have to remember to set whatever's inside here equal to 5, and whatever's inside here equal to -5. That's all I'm saying.
Okay.
Maybe it's too confusing.
I'm sorry.
Maybe it's just too confusing. That's what I'm trying to say over here. So you've got both of these cases. What's inside has got to be +5 and -5 for it to work. So that justifies these 2 equations.
Yeah, I see it now.
Okay. All right, well, you're going to do the same thing on both these equations. You just got to watch these sign differences. I prefer what's called the I hate fractions method. So I'm going to look at 3 and 6, get a common denominator of 6. Since 3 goes into 6, you can use the higher number. I'm going to multiply through by 6. I'll write it out real slow. 6 times 1/3 x minus 6 times 5 over 6 equals 6 times 5. We'll do this one on the next page. So on these fractions, the 3 will cancel into 6 twice. That'll leave a 2x. 6 completely cancels. That leaves a 5 minus 5. Over here, we get 30. Were you losing anybody? All we got to do is add 5 and divide by 2. Add 5. 2x equals 35. Divide by 2, your x would be 35 over 2, 35 halves. Is that too fast?
No.
Okay, we're about to go on to the second case. Got to repeat the same steps, multiply through by the 6, but this 5 is going to be negative, so it's going to give us different numbers. So 1/3 x minus 5 over 6 comes up negative 5. Multiply through by the 6. I'll shorten it up, just write the 6 sides. You still get a 2x. You still get a minus 5. That's identical. 3 into 6 twice. 6 completely cancels here. But over here, you're getting a negative 30. Not a positive like the other case. Going to add 5 and divide by 2. Plus 5. 2x then would be negative 25. Divide by 2. I come up with negative 25 halves. So my two answers, I believe I had 35 halves on the other page, negative 25 halves here. A little tougher to put this in and check it, unlike the easier number 11. So you might want to check the back of the book. They could have decimals. I guess this would be 17 and a half, 17.5, and this looks like negative 12.5. Either form is fine. Any questions about that? Anybody want to see anything from 1.7 that we covered Monday night, or do you want to charge into the new stuff? The section right below this on page 153 is absolute value inequalities. I can show you a few of those to get you started on that, and then I have to show you 110 because that's on the test this weekend as well. Y'all want to charge into that?
Yes. Yes, that's fine.
Okay. Let me, we'll just charge into 23. It's a really simple one. It gives the ideas. These are absolute value inequalities. All right, 23, solve absolute value of x less than or equal to 5. Okay, let's compare to absolute value of x equals 5. And you'll see what difference going to an absolute value makes. All right, so this is just a straight x. There's no other algebra to do. If I drew a number line, you'd have negative 5 and 5. You'd have closed circles on both of those. And you'd say x equals 5, x equals negative 5, and you're done. Absolute value 5 equals 5, absolute value negative 5 equals 5. Those are the only two numbers that work. so they don't make you graph them. But when I stick a less than or a greater than on this, it's going to make intervals. And we've got to find, it's going to be intervals between these numbers, and we got to find them. Okay, so you're still going to do this same thing because there's an or equal to. In fact, even if there's no or equal to, you're still going to do this same thing. All right, so you have a number line, and you're going to have -5 and 5, and you're going to have closed circles. If there was no or equal to, I'd have them open. Okay, so now I've got to test which of these intervals are going to have x numbers that are less than or equal to 5. You can literally test almost like last section. -6, absolute value -6, less than or equal to 5. Well, the absolute value -6 is 6, less than or equal to 5. No. Well, you can. Are we losing anybody maybe before I check the other two?
No, you're good.
Okay. So we'll try, say, number in between, always like 0. Absolute value of 0, less than or equal to 5. Yes, 0 is less than or equal to 5. Yes. So we're going to shade between the 5s. You probably can see if I come the other side of 5 to 6, it's not going to work anymore. Absolute value of 6, less than or equal to 5. 6, less than or equal to 5. No. So my answer, -5, 5 in interval notation with brackets. All the numbers between -5 and 5, including -5 and 5, will work. Now, with a simple x, you can just test things. When we go further down the page, you get a little more algebra and things, and you kind of start this way, and then you've got to solve. I guess I'll show you that further down. Let me just show you just the third case. This isn't on the page, just for what if you'd switch to a greater than, absolute value of x greater than or equal to 5. Can you tell it's going to mirror image this? You're still going to have your -5 and your 5. But now your -6 over here, when you test it, absolute value -6, greater than or equal to 5. 6 greater than or equal to 5. Yes, this works. Can you tell the number in the middle is not going to work? Absolute value is 0 greater than or equal to 5. So 0 is greater than or equal to 5. No. 0 is not greater than or equal to 5. And 6 over here is going to work. Greater than or equal to 5. Yep, 6 is greater than or equal to 5. Yes. So these are really the two cases. If it's straight equals, you only get the exact numbers. If you're less than numbers, you're going to be between the positive and negative of those numbers. And if it's greater than, you're going to be outside them. The interval notation, just to complete it, your interval notation, -∞, -5 with a bracket. Usually use a U, bracket 5 to infinity. Are we losing anybody? Not getting any response. Is this
Yeah.
clear as Lake Lanier? Are y'all ready for another one?
Yes.
Let's
Yes,
try
sir.
30. Okay, let's try 31. Still off page 153. Absolute value of 2x plus 1 greater than or equal to 3. All right, you can set up the initial number line, and you'll need the negative of it and positive of it. With the or equal to, you'll need closed circles. Okay, now this is where it gets a little tricky and technical. Same idea. See, with a greater than, you're going to be outside the threes. See over here for like -4, an absolute value of -4 greater than or equal to 3. So 4 is greater than or equal to 3. So this works. Numbers in the middle do not. Absolute value is 0 greater than or equal to 3. No. And can you tell the 4 will work? Absolute value of 4 greater than or equal to 3. 4 greater than or equal to 3. Yes. Okay, now if this was a straight X, this is the only number line you need. But it's not. You've got to zero in on this X. So what you really have is 2x plus 1 here for all the shaded stuff. The 2x plus 1 is this side of -3, and it's also this side of 3. We'll call this one case 1, this one case 2. This one should be obvious. Your 2x plus 1 is greater than or equal to 3. Most people get that just exactly like it's written. But over here, your 2x plus 1 has got to be less than or equal to -3 because you're on the left side of -3. If we solve these two equations down for x, we'll create a new number line in x, and that'll be our answers. But before I do that, let's pause for station identification. Are we losing anybody?
No, sir.
Everybody capable of solving these? You do the same thing on both. Subtract 1 and divide by 2.
For the testing numbers, basically on this one, we were testing to see where we would.
Where you would stick the 2x plus 1.
That's what, okay, that's what I thought.
If it's a straight x, it's like that last problem 23 and you're done. But if it's got other blob stuff in, then you're testing the 2x plus 1, and that's what you've got to set. Less than or equal to -3 and greater than or equal to 3.
Okay.
Zero in on x itself. So we're going to go -1, -1. 2x will be less than or equal to -4. Divide by 2, divide by 2. Remember, watch for this being a negative. If it ever was, you'd have to switch this. Your x is going to be less than or equal to -2. Over here, same thing, -1, -1, but that's 2x greater than or equal to 2. Divide by 2. X is greater than or equal to 1. Are we Going too fast?
No.
So now if you can write down your interval notation from this, help yourself, maybe you can get some practice. I'll go ahead and show you. You'll have -2, closed circle, because it's got an or equal. 1, closed circle, it's got an or equal. If you're less than -2, you're this side of -2. And if you're greater than 1, you're this side of 1. If you want to see for the interval notation, infinity over there, negative infinity here. So your answer, negative infinity, -2 with a bracket, bracket 1 comma infinity. To give you some confidence in this, let me see if I can find it in the back of the book. Risk looking like an idiot. If I got it wrong, if I did something wrong, let's see what the, okay. This is 1.8, problem 31. Okay. Try to hold it up to the camera if y'all can read it here. Okay, 1.8, 31. I don't know if I can get both on the screen here. 31 up here, let's see, where what? Yeah, negative infinity, -2, notice the bracket. Union the 1 bracket with infinity. And that's exactly what I've written by hand down here. Theirs is neater because typewritten book. It looks neater in a typewritten book than with my scratching. Does anybody want to see any more of those, or are you ready for 110? Oh, we're 37 minutes in. Are you ready for 110 to see what a few of those look like?
Yes, but I had a question.
Okay.
For the test, is it gonna be? It's gonna be true and false, right?
Yes, it is.
Okay, so are we just gonna be looking at your notations, or do we need to look at if you did the graph right as well?
Well, the final answer I'm going to show you is going to be an interval notation like this. Or I may have a, yeah, I may, let's see, that last section wanted you to do that one section wanted you to do 3 things: solve, graph, and write an interval notation.
Mm-hmm.
So yeah, if it looks all consistent and everything looks correct, you'd mark correct. If any piece is wrong, you mark the whole thing wrong.
Okay, that's what I was wondering.
Yeah, if the graph is wrong, but by interval notation is right, it's inconsistent. So you mark the whole thing wrong.
Okay, thank you.
Uh-huh. Anybody want to see another one of these? Or you want to see something from 110?
110, please.
110, okay. Just give you a brief introduction to it. The title of it is called Modeling Variation. We give you 3 kinds. Variation. They're going to give you 3 phrases, in other words, 3 phrases to translate. All right. The first kind is called direct variation. And they'll say y varies. A lot of words in this, but I've left off the word problems at the end of the section. And I'm going to keep the simple words like this: directly with x. All right. They want you to translate it. So what you do is you start with whatever letter they give you. When you see this word varies, you write in equals, and here's the rub. they use a letter K. They want you to write a letter K on every one of these, even though they don't show it. And then you finish with directly, you stick whatever letter they give you right beside it, you're multiplying them. The K is a constant of proportionality. It's in every one of these when you see this word varies. Proportionality. Okay, and what they mean by varies directly is that X and Y do the same thing. In other words, can you see if X increased, Y increases. X decreases, Y decreases. They do the same thing. Number 2 is called joint variation. And all it is just multiple letters. Multiple letters. So they might say Y varies directly with X and a Z. You'd write Y equals K. You always write Y equals K on all of these. And then they'll give you multiple letters, and it works exactly like direct. They all go on the same line. And it's the same thing. Any of these letters increase, Y increases. If either one decreases, Y decreases. They behave exactly the same. The third kind is called inverse. Third kind, Y varies inversely with X, let's say an A, X and an A. Y equals K. Inversely means they behave opposite. To get that to happen, in other words, X goes up, Y will go down. Anything after the word inverse goes on the bottom of a fraction. So if X goes up, this overall fraction goes down and Y goes down. Same thing with A. A goes up, this overall fraction goes down, Y goes down. So A up, Y down. If these numbers go down, you decrease the bottom of a fraction, the overall fraction gets bigger, Y will go up. Now they will give you some where they combine these. Just try an example of that. Y varies jointly with X and W and inversely with A and B. Y equals K for the Y varies. The jointly keeps on the same level. Anything after the inversely goes on bottom. All right. This might, hope all these words aren't confusing you. This might come across like real gibberish. I'll try a couple problems here. Trust me, easiest problems in the whole chapter. Anybody want to ask anything before I show you some couple examples out of the book?
No, go ahead.
Okay. So these are on page 164. Okay, I guess we'll just start with the first one. Is number 7. T varies directly with X, or as X. They're saying as X. They just want you to write an equation. That's the way they word it. Write an equation. You start with T, varies equals K, and they got just one letter, X. That's all they want. Hard to make this complicated. How about, oh, okay, further down, they start to use the word proportional for direct or so. So like number 11, y is proportional to s and inversely proportional to t. You start off y equals k. Proportional works just like direct, so the s would stay on top. Inversely, the only letter after inversely is t, goes on bottom. All right, in the next section,
This
go ahead.
this really has nothing to do with numbers, mainly letters.
In this first section, yes, problems 7 through 18. Now, we also assigned the next section, 19 to 29, and they gave you numbers in those to find the K. You want to see an example of that?
Yes, please.
Okay. This is page 164. First one's 19. Y is directly proportional to X if X equals 6, Y equals 42, and they want you to find, they write it out in words, the constant of proportionality. Of proportionality. In plain English, they just mean find K. All right, so you first write your equation, y equals K, and directly proportional just puts an X there. Now you look to these numbers, notice that they've got to give you every other letter but the K. So I sub in 42 for the Y, K, 6 for the X. All I got to do, undo that multiply, divide both sides by 6. Cancel the 6's, 7 equals K. Or you could say K equals 7. That's really all they ask for. Sometimes they want you to find the formula, but they're really not asking you to do that. And it would be y equals 7x, but you don't really have to do that. And there are others further down in the section to problem 29 that, get a little more, kind of got more letters in, more numbers. But I don't think you should have, a whole lot of problem with it. We're not asking for the word problems later on. Don't thank me all at once. Do you want to see any more? Let me try one more. Go ahead.
I mean, if you want to show another one, it's up to you.
Yeah, I'll be happy to. Or am I boring the heck out of you? We're 50 minutes in. It's up to you. Would one more kind of drive it home?
Yes.
All right. How about 20? Well, you pick a whole bunch of different ones in a. All right, how about 25? Page 164, 25. W is inversely proportional to the square of R. The square of R. If R equals 6, W equals 10. And they don't give you the find K right here on the problem. It's back in the paragraph above, but they want you to find K. Do you read square of R to be equal to R squared? If they wanted square root, they'd use the word root. So you go W equals K. There's not the word direct or joint here. They just only have the word inverse to basically R squared. If you're inverse to R squared, that puts the R squared on bottom. Any questions about that before we charge into the numbers?
No, sir.
No.
Okay. So we're going to sub in W equals 10, K, and R is 6, so that's divided by 6 squared. 10 equals K divided by 36. All you got to do is clear the fraction, multiply both sides by the 36. Multiplying by 10 just adds a 0, puts a 0 on it. 360 equals K. Is that too fast?
No.
All right, we're at 52 minutes in. The test will be available tomorrow. It will work exactly like the quiz. It's just going to have a longer, more breadth, cover all of chapter 1 instead of just the material for this week. I'm going to write this out, but basically it's due Sunday night. But, there's always a few people who have a few fits or whatever. Ordinarily, I'd give a 1-day grace, which would be cut it off Monday night. But it's Labor Day weekend, so I'm going to extend it even a day beyond that. I'm going to give everybody till Tuesday night to turn it in. I'm going to cut it off Tuesday night and not look at any submissions. When you submit it, it puts the date and time. So I need it submitted no later than Tuesday night, even though I'm calling Sunday night the due date. And it's going to work by the same rule. It's going to be under the test button, the D2L, and it'll have a Google form right below it that you'll put your true and false answers on. So if this was on the test, this problem was on the test, you'd look down through it. You could work it yourself, see if you get the same answer as me, or you could look down through, try to grade, see if you can spot where I screwed it up. But if you think I did it correctly, you'd put down true on the Google form, and if you think I screwed it up, you'd put down false. Any questions?
No. Thank you, though.
No, thank you.
Okay, are we ready to end the meeting then?
Yes.
Yes, sir.
Okay. Appreciate y'all coming out this late. And hope y'all have a good Labor Day weekend. Thank you for coming out. We'll end the meeting.